All right. Hope my screen is visible.
Yes, sir, you're visible.
Yes, sir.
Yes, sir, it's visible, sir.
Okay,
Yes.
great. So, welcome everyone and good evening, all of you.
Good
This,
evening,
this
sir.
is the second revision session for statistics for data science course, right? So, in today's session, we will be revising weeks 3 and 4. All right. So, already revision session 1 has been happened, and in that we have discussed week 1 and 2, right? So, in today's session, we will kind of maybe I will give you some important concept that you should definitely focus on for quiz 1 or the qualifier. Okay, along with that, we'll do problems and we'll try to revise and we will stick to quiz 1 syllabus. Okay, so and that too important concepts related to quiz 1. Okay, so let me start with, so I think 20 people we have, so I think we can start. So we'll start slow.
Emphasize more on variance, standard deviation, and covariance and correlation, sir. Well, because those are all the formulas a bit confusion and the calculations part and where we have to focus.
Okay, so we'll do that.
Thank you, sir.
Okay, yeah. All right, so out of all the concepts, there are few concepts which are really important with respect to week 3 and week 4. And they are basically you should know how to organize and describe your numerical data. Right. So in week 3 and week 4, we kind of deal with numerical data. Especially in week 3, we deal with numerical data. And we can organize this numerical data using frequency tables, bar graphs, histograms, and stem and leaf diagram, right? So frequency tables are used for both discrete and continuous variables or continuous data, whereas bar graphs are used only for discrete data, right? Histograms are used for continuous data, and stem and leaf again you can use it for both discrete and continuous data, right? So we'll see everything with an example, but representing them is one part. After you represent them in the required tables or graphs, you should do some analysis, right? You should do some descriptive analysis. Uh, in that, they will be measuring few things. One of the two of the most common measures that we do are measures of central tendency and measures of dispersion. Measures of central tendency is where the data is centered, where we compute mean, median, and mode, right? So these are measures of central tendency. And it's not only sufficient to just check where the data is centered. You should also check from the center, how is my data set got spread, right? So it is called measures of dispersion. And there are many measures in measures of dispersion, starting with range, variance, standard deviation, and the quartiles. And finally, we'll also compute interquartile range. So interquartile range is also one kind of measures of dispersion. Uh, just a second. Somebody posted something in the chat. Yeah, so I'll also take doubts at the end of the session. Let me finish whatever I came with or the agenda of this today's session, and then I'll take doubts. Okay, I'll keep it open. Okay. Just a second. All right. So let's continue. And we'll also do examples. One nice example that covers all this mean, median, mode, range, variance, standard deviation, IQ, or everything. Okay. So that sums up week 3. And with respect to week 4, we will study association between two categorical variables. And how do we measure that association? We measure it using this row frequencies and column frequencies. Right, so we compute them, and based on the rows frequencies or the column frequencies, we conclude whether the two categorical variables are associated with each other or not. Right, and once we are done with categorical variables, we'll also do study on association between two numerical variables. Like the best way to describe this is using scatter plots. Right, and this categorical variables, best way to represent them is contingency tables. So it's called contingency tables, right? So we'll see them.
And there's SST sum of squared errors and total sum of the squares. This will be in this the same topic of statistics also there, no sir? Actually, we are dealing with the coordinate geometry, but it is more concerned with statistics, if I am not wrong.
Okay, so this sum of squared errors and everything is comes when you try to fit some data to a line, right? So how best is the line and everything, right?
Yes, sir.
So it comes in both, right? So whatever comes in stat comes in math, comes under math. Okay, but
Yes.
that's not the discussion here, right? So let's not get into too much of technical discussions. Let's keep today's session as simple as possible because we are preparing for quiz one, right?
Yes. Yes.
So given a problem, how should we able to solve it in the fastest way that is possible? Okay, so that is going to be our main agenda, and I will also talk about theory, but we'll focus more on problem solving because that is more important. Okay. All right. So, and between these two numerical variables, the association is measured using two things. One is covariance and another one is correlation. So, we'll see how to compute this covariance and how to compute the correlation coefficient, Pearson's correlation coefficient. Okay. So, with that, we will end. We will not be discussing this straight line fit and association between numerical and categorical. But it is kind of not important for quiz one, at least. Okay, so if we can cover these things within 2 hours, it's a big deal. No, you will not be allowed to use Google Sheets or anything. Okay, so that is why the data sets that you are going to see in the exams will be very small. You will see at max of 10 data points. Okay, which can be computed with hand. Okay, all right, so let's see each and everything in detail. So let's start with organizing the discrete data. Okay, so how do I organize a discrete data? So for organizing discrete data, as I said above, there are two ways. One using frequency table and another one using bar graph. So we'll take an example and draw the frequency table and also the bar graph. Okay, so let's take this example. Suppose the data set reports the number of people in a household, living in a household, and data of responses from 15 houses are given to us. So 3, 2, 1. So this 3 is like in the first house, so there are 3 people living in that. Now, how do I construct the frequency table and how do I compute the relative frequency? Right. So how do I construct the frequency tables? So I'll see what all values are there in the data set. Right. So what are the values? So values are, there is 1, there is 2, 3, 4. So there are 4 values, right? So I will draw a table with the 3 columns. And 4 rows. So 3 columns. Right. So the first column contains the values. The second column contains the frequency. Frequency is the number of times that value has occurred in the data set. And then comes finally the relative frequency. So it is very, very important that computing relative frequency. Okay, so let's remove this. Okay, so now you guys tell me how many values are there in this data set.
15.
Okay, so value, I mean
1
number
to
of
3.
different values. Yeah. So
1.
1,
1, 2,
2,
3, 4.
3, 4. And what is the frequency of value 1? How many
1.
times?
One,
One,
sir.
one time. And what is the frequency of value 2?
6. 6.
Six.
So we can count 1, 2, 3, 4, 5, 6.
Yes, sir.
So it is 6. Frequency of 3,
It's
4,
1,
4.
sir.
2,
2,
4. 4,
3,
sir.
4. Right, 4. And finally, frequency of value 4 is
It's
4,
4.
4,
sir.
sir.
It's
4.
4.
So this is the frequency. How do I compute the relative frequency?
Frequency by
Frequency by total
total
number of
frequency.
observations.
Yeah. So the total frequency will be the total number of observations.
That's
Right?
15.
So it will be 15. So for computing relative frequency,
1 by 15.
I take 1 divided by 15. And the second value 2 has relative frequency 6 by 15. Similarly, 4 by 15 and 4 by 15. If I add all the relative frequencies, what will I get?
1, sir.
1.
So you can cross check your answers.
Yeah, it's 15 by 15. 1, sir.
Yes. So it will give us 15 by 15, which will give us 1. Okay. So 1 by 15, 6 by 15, 4 by 15, and 4 by 15, you can compute. So computation parts I will not be doing. I'll just show you how to compute. So you
Sure,
can
sure.
compute and see. So this is how we represent or describe this data set, right? And there is one more way, which is using bar graphs. So what are bar graphs? Bar graphs has x-axis and y-axis. And x-axis contains the values, right? So values 1, 2, 3, 4. Observe that these are discrete values. So 1, 2, 3, 4 are discrete, right? So there is no value that is between 1 and 2, between 2 and 3, between 3 and 4. Right. So now what? This is the values are on the x-axis, and on y-axis we will have the count. Right. So x-axis contains the values, y-axis contains the count. So we will just draw a rectangle of height that is equals to the count of that value. Right. Understood? So one frequency
1,
is 1. So it will have height equals to 1.
1.
Okay. So this will be 1. So like this, the height of the rectangle at value 2 will be exactly the count of the value 2. Here it is 6. So the value 2 frequency is 6.
Highest one.
Yeah. And similarly, value 3 has this, and value 4 is also exactly the same. So you can clearly see that none of the bars, so we call these as bars, 4 bars, are touching each other. So bar graphs, when you plot bar graphs, these bars should not be connected. Okay, so there will be a space between each and every bar. Okay.
Yeah, unlike histograms.
Unlike histograms. For histograms, we will have the bars connected to each other.
Yes.
Okay, and histograms are plotted for continuous, bar graphs are plotted for discrete. So that is
Discrete.
also one more difference.
From the graph, we can term the mode is 2, sir.
Yes, from the graph, we can clearly see that the mode is 2. We can also compute mean and median also. Okay, but from this bar graphs gives us which value is highest. There you can compare between the values. Okay, even this table also gives the same thing. Whichever has the highest relative frequency is the mode. Right. So these are two ways of representing discrete data, numerical discrete data. Okay. So now how do I organize continuous data? For continuous data, there are certain rules that we should follow. Since the data is continuous, we can't plot each and every data point as separate value and plot bar graphs. That will look absurd, or it's not very clear. For that, what we do is we follow certain rules or guidelines. First of all, we determine some classes. So we fix some classes, or we group some data points together. Okay. And how many classes should I take is a subjective thing. It depends on the data points. But there is a general rule that we should be having classes between 5 to 20. So how should I write this? So there is no fixed rule as such. So you can have more than 20 also, but we usually follow in any of the data analysis that we do. Usually will not have more than 20 classes or lesser than 5 classes. Okay. So classes should be between 5 and 20. So that is one rule. And the second one is, once you create these classes should be mutually exclusive. So what do I mean by mutually exclusive? Each observation should only belong to one class. Okay, it should not belong to, no observation should belong to two classes. And the third rule is, each class should have equal length. Okay, so equal interval or equal length. So class interval should be of equal length. Okay, so these three rules we should follow. And as I said, when you group the things, we'll see it with example also. But when you group things, you should group it in such a way that each observation should belong to only one class. And also the number of classes that you choose should lie between 5 and 20. And the class intervals that you are going to choose should be of equal length. Okay. And there are some terminologies also that I will talk along with the example. So we'll see one example which is continuous data. So marks are continuous, right? So it will start from some 0 till 100. So when you have the marks of some students given like this, then if you try to think of this as a discrete and try to write the frequency tables and then plot bar graph, it will look like each of them will have frequency 1 or at max 2, and you will have too many values, right? So some 18 or 17 values you will have, which doesn't say anything about this data. So the best way to do it is we group this whole thing into some classes. So the classes that we are going to choose are, we'll say 30 to 39, or we'll say 40, and then 40 to 50. See, there are different notations. If you say that when you determine these classes in this way, the right hand side point will not go into this class, rather it will go to the next class. So each class contains from the leftmost point to one less than the rightmost value of that particular interval or class. Okay, so you can think of it like that, or for better clarity, you can divide your classes like 30 to 39, 40 to 49, 50 to 59, 60 to 69. Okay, so you can do anything, but let us should also, okay, let's follow what lectures follow, what ma'am followed in the lectures. Okay, so we divide, and there is 70 to 80 also, right? So we divide this whole data set into 5 different classes. So the first class is 30 to 40, second class is 40 to 50, 50 to 60, 60 to 70, 70 to 80. But at the end points you see, right? So this 40, 50, 60, 70. So this 40 will fall in this class, not in the first class. Even 50 falls in the third class, not in the second class. So like that, 60, 70. So each class contains the marks starting from the lower class limit. So this, each and every class will have 2 limits. One is lower class limit and upper class limit. So this leftmost point or the least value in the class is called the lower class limit, and the rightmost value is called upper class limit. Okay, and class width is one thing, which is the difference between the lower class and lower class limit and the upper class limit. Okay, so class width is simply 10. 40 minus 30, the 50 minus 40. So the class width is uniform across the classes. And there is also class mark. It's not that important, but it's good to know. Class mark is basically the average of these two class limits. So upper and the lower. You just take the average of it, which is 35 for the first class, 45 for the second class, 55 for the third class, likewise. Okay, so that is called, yes.
Maximum
The class width,
can accept in the first is up to 39 only, no, sir?
Yeah,
30.
so that is what I'm
so
going
class
to.
width should be 9, right?
No.
No, class width is starting from 30 to 39, right? It's not 31 to 39. So it contains 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. So it will be 10.
Okay, okay. Fine.
Okay.
We will have one more class now, 80 to 90 also, because 88, 86 and 82 are also there.
Yeah. So there is one more class. Yeah. So 80 to 90. Okay. And each and every class, as I said, it contains the left end point or the lower class limit, but not the upper class limit. So upper class limit will not be in that particular class. It will go into the next class. That is what I said, right? So 40 will be in this class, not in the first class. Okay. So these are few things that you have to keep in mind when you create classes. So once we create classes or the class intervals, we plot the frequency table.
Frequency table.
So we'll plot it here. We will draw it here. So we'll do the same thing, just like how we did for discrete case. So now here also it became discrete, right? So 30 to 40, you think of it as one value. 40 to 50, you think of it as another value. 50 to 60, you think of it as another value. Okay. So this is the frequency table. And this is class interval. We'll not call it as value, but rather we'll call it as class intervals or simply classes. Okay. And then the other two are the same, frequency and relative frequency. Okay, so class intervals 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, and 80 to 90. Now all we have to do is we have to count how many data points are there in the interval from 30 to 40. So if you can count, it is 38, then 35,
Three,
then
sir.
39, 3. So all this 38, 35, 39 falls in this class 30 to 40. So the
Sir,
frequency,
even 37 at last second.
There are four.
yeah,
Four.
37, 35, 38, and 39, right? So it is 4. So we should be really careful when we draw this frequency tables, okay? And frequency of this class interval 40 to 50 is, you just have to see the number of data points that are there in the interval 40 to 50. You should not count 50 if at all 50 is there, but you should count starting from 40 till 49. So it is 45,
Sir, there are two.
44, only 2, right?
Yes, sir.
Yes.
Only 2. And similarly 50 to 60, if we count 58, 54, 58,
55,
3,
52.
4, 5. So there are 5. So the frequency will be 5. Then 60 to 70 is, again, you should not count 70. You should not, because 70 goes into the next class. So 68, 62, 61,
61,
65. So it will be
4.
4. Then 70 to 80 is 70, 79. That's it.
2.
So it is 2. It is 2. And then 80 to 90, you can see that it is 86,
3.
88, 82. 3.
3. 3.
Right. So if you want to verify whether we have got the correct frequencies or not, you compute the sum of the frequencies. Sum of the frequencies should give us the total number of data points.
20.
It should be 20. If you count 4 plus 2 is 6, 6 plus 5, 11, 11 plus 4 is 15, 15 to 17, and 3, 20. So it's correct. More or less it's correct. Okay, so now relative frequency is basically 4 divided by the total number of data points, 2 divided by total number of data points, 5 by 20, 4 by 20, 2 by 20, 3 by 20. Right, so this is the frequency table for this continuous data. And there is another way of representing this continuous data, which is histograms. So histograms also contains x and y axis.
Sir, can you just explain again relative frequency? Just one.
So the
Third.
relative frequency is same as discrete case. So all we have to do is you take the frequency of that class interval divided by total number of total frequency or total number of data points. So the total frequency, if you compute, it will give us 20, right? Total frequency is basically the sum of all individual frequencies. So the relative frequency will be frequency of that class divided by total frequency. That is why we divided every frequency with 20. That becomes the relative frequency. Okay.
How did you calculate the 20? This can you tell me?
20 is basically the sum of all the frequencies. Sum of all these values. 4, 2, 5, 4, 2, 3. Okay. Okay. So now coming to histograms, what we have to do is we divide this x-axis into intervals. So now this has order. Okay. Whereas discrete case, previously discrete case, 1, 2, 3, 4, or you can just put 2 here, 1 here, 3 here, 4 here. It doesn't change much. They are just discrete values and they are just different classes, you can say. Whereas
Sir, in
here,
discrete, we have to use only bar graph, or we can use histograph also.
yeah, that is what I am saying from the start. Histograms are used for continuous data, not for
Okay.
discrete data.
Okay.
Okay. All right. So here, if we plot the histograms, we will first plot this scale. Right. So this is 30, 40, 50, 60, 70, 80, and 90. So now the rectangle will be of the rectangle width will be class interval length. The rectangle height will be the frequency of that class interval. Okay, so here for the first case, so the class interval 30 to 40, frequency is 4. So the rectangle width or the length, sorry, the length will be 30 to 40, which is the class interval length, and then the height will be the frequency. Okay, so this is 4. And the next rectangle will come immediately, touching the previous rectangle, previous bar. Okay, so between 40 to 50, the frequency is 2. So it will exactly
Height
be,
of the histograph is 2.
yes, so the height of this bar will be just 2. But if you see here, both the bars are touching each other. Similarly, 50 to 60, the frequency is 5. So the height on the histogram of this bar will be 5. Similarly, 60 to 70, it is 4. 70 to 80, it is 2 again. 80 to 90, it is 3. All right, so this is the histogram of the given data. So this will be 2, this will be 3, this is 4, and this is 5. Okay, again, this is class intervals on the x-axis, and here again the count or the frequency on the y-axis. So this is the histogram. Okay.
Sir, from the table, can we compute the median and as well as the mode, sir? The corresponding, we are getting 3.5. Generally, the frequency 3.5 as the median. For the 3.5, which we have to assign to the class, sir, if we ask about the median.
So what is the median here? How do you compute the median?
We can keep the frequency in an order, and it comes as 2, 2, 3, 4, and 4, 5. And that would be 3 plus 4 by 2.
That's not how you compute median in this
So that's
class.
why we have to go to the class interval, sir.
Yeah, we have to see the data, right? So data from the data, there are 20 observations, right? You have to order all the 20 observations
Okay.
in order, and then you compute the middle point. That will be the median, right?
And for the mode part, can we take it as 50 to 60 as the mode here?
No.
No, right? Again,
The more frequency is at 50 to 60.
Mode frequency is between 50 to 60, but when you group all of them and think of it as like think of it like discrete data, then you can say 50 to 60 has high number of data points, but it is not called as mode. Okay, so this is a continuous data where computing mode or median, you have to look into the observations, order them, compute the median, and uh, mode is the value that is repeated most. Right, so
If
here I
none of
think
the values are repeating,
there is no mode. If none of the values are repeating, then there is no mode for this particular data set.
okay.
Mode can be zero, na?
Mode can be
Zero.
no, right? So mode is not zero. So no mode is different from zero mode. So when you say mode is zero, so that means zero is an observation that is repeated the most in the given data set.
So null mode we have to say.
Sorry?
Then mode is null here.
It's not null also. There is no mode for the given data set. No mode.
Okay.
That's it.
Okay.
Okay. So mode comes into the picture only when at least one of the observation is repeated twice.
Sir, what would if the middle part was two numbers?
Then we have to take the average of it. We will come to
Average.
there. So we are not done yet. So we'll come to there. See, when we come to this descriptive measures, we'll talk about mean, median, mode, and everything. Okay.
Okay.
So we'll come to mean, median, mode in 5 or 10 minutes. Okay.
So from the frequency table, telling 5 as the mode is not correct. Why? Because the most occurring frequency is 5. We should not consider in this particular pattern of data.
Yes, in this particular pattern of data.
But in discrete, if any frequency is highest, then that is considered
Correct.
as mode, right?
Correct.
Got
Correct.
it. Thank you.
Okay.
Okay, sir.
So the next way to represent is stem plot. And I hope most of you know how to represent any given data in stem plot. So each observation is separated into two parts. One is called stem and another one is called leaf. Stem contains all the digits except the rightmost digit, and leaf contains the rightmost digit. So for
Oh.
example, if you have 3275 as your observation, 327 is your stem, 5 will be your leaf, and the representation will be stem will have 327 like this and leaf will have 5. So if you have one more data point like 3277, so if you have one more data point like 3277, then this is stem and this will be the leaf, and the representation will be 327 followed by leaf is 5,
7.
and with some space you will have 7. Okay.
Sir, how do we represent a decimal? Can we represent a decimal number in the stem plot graph?
We can, but that is out of scope for now. So we don't really deal with the decimal values right now.
Okay.
And one more doubt is here we took two observations, 3275, 3277. So here in the representation we wrote stem as 327 and leaf as 5 and some space 7. That is
Yes.
happens when stem of these both observations are same, right? If we have some stem as different than what?
Stem is different, then you write the stem in below and then
Okay.
put that 7. So we will see this example will clarify that.
Okay.
Right, let's say we have a simple data set of 5 observations. If I have to draw a stem plot for this, first of all, I'll have stem and leaf, right? And look at how many stems you have, right? So
1 is the stem and 5 is the leaf here.
yeah, so 1 we have
5.
one is stem, 2 is also a stem, and
3 is
3 is
also
also
stem.
a stem. So you can
First stems.
just write stems first. 1, 2, 3.
Yes.
So 3 stems you have. So now see how many leaves are attached to stem 1.
3 and
5
5.
and 3.
So there is 15 and 13. So 3 and 5 are the leaves for the stem 1. So what we write is we will write them in order. 3 space 5.
Order is must be followed, right?
Yes, order must be followed.
Okay. So
So
better to
this,
rearrange first and do.
yes, better to rearrange first and then do. So this reads 13 and this reads 15. Similarly, look at how many leaves are there for the stem 2. 20 and 22. Right? So we'll have 0
and 2.
and 2. Again, here also this reads 20. This reads 22. Okay. And finally, stem 3 has only one leaf, which is
6.
6. And this is the stem and leaf plot. And this stem and leaf plot is very useful when the data set is smaller. Okay, if you have some 50 data points, it's very hard to plot this stem and leaf. Okay. So yeah, so that is one way.
Sir, the
So all,
stem should also be in ascending order, right?
yeah, stem should also be in the ascending order.
Okay.
बता रहे हैं order has to be followed.
Sorry.
No, sir, no. Nothing.
Okay. All right. So let's come to the main thing. Once we plot the data or the plots are given to us, as of now, that is what we did, right? So given the data in any form, we should know how to read the data. For that, whatever we did so far is helpful. So once you are able to read the data properly, then you have to measure few things that are asked. Right. So the most frequently asked ones are mean, median, mode of any data set, which are measures of central tendency. Right. So first one is mean. Mean is basically average of
All the frequencies.
average of the data given. Right. So mean is also referred to as average. Right. So mean or average is basically what you have to do. You have to add all the data point values, all the data points divided by
Number of
number of observations.
observations.
So it is simply sum of all observations
The total number of observations.
divided by total number of observations. Okay, very easy. There is sample mean, population mean. Both have the same thing. For sample mean, you take the sample sum divided by the number of samples you have. If it is population mean, you add up all the data points in the population divided by the number of data points that are there in the population. Same. There is no change at all. Okay, so I'm not writing it, but it is the same. Okay. So next comes median. What is median? Median is basically the middlemost point.
Middlemost part.
Basically, 50% of the data lies to the left of that value and 50% of the data lies to the right of the data on the number line. Right. So if you plot all your data points on the number line, since this is numerical data, you can do that. Right. If you plot all your data points like this. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 data points, right? So you have to take the value such that to the left of this value, there will be 50% of the data. So if you have 10 observations, 50% of them are 5. And your value should be after 5th observation. So 1, 2, 3, 4, 5. So your median should lie somewhere here, where you can clearly see that 5 observations are to the left and 5 observations are to the right. It doesn't matter how far each and every observation is. We will still take the median to be the centermost value of the observation. Okay, since here I have taken even number of observations, median turns out to be
n/2.
5th and 6th observations mean. Right, so this is the 5th observation and this is the 6th observation. And how am I saying it is 5th and 6th? You should order your data set first. So for computing median, always remember that you should order your data. Then the first observation or the least value that you see will be the first observation. So this will be the first observation. So like this will be the 10th observation. So if your data has even number of observations,
Then the middlemost.
not the middlemost, right? So for even number, there is no middlemost, right?
It will be mean of the n by 2th plus n by 2 plus 1.
So here you can see for 10 observations, I can equally divide 10 into exactly half, right? So 5 observations and 5 observations. So my median should be in between them. So when it has to be in between them, then it is not exactly the observation 5th observation, nor it will be 6th observation. It will just be the mean of this 5th and 6th observation. Is this understandable? I will write it. If the number of observations is even, then the median is the mean of n by 2th observation and n plus 1 by 2th observation. Okay, so if you are confused with n by 2, n plus 1, n by 2 plus 1, sorry. Okay, if you are confused with this, you think of it like if it is even, you divide it into half. Okay, so that observation you should consider and the next observation and take the mean of them. Okay, but if it is odd, then you can simply take n plus 1 by 2th observation. If number of observations is odd, then median is n plus 1 by 2. I'll just take small example. So let's say 1, 2, 3, 4, 5. Okay, so ordered. I have only 5 observations, which is odd. So I can clearly see the center value, right? Left of 3 and the right of 3 has equal number of data points. Right? So it is 3 sits exactly at the center. Right? So if it is odd, you can clearly find the median to be. So here in this point, median in this data set, median is, there are 5 observations. 5 plus 1 by 2th observation is median. So 5 plus 1 is 6, 6 by 2 is 3. So if you count, third observation will be the median. Whereas if I have 1, 2, 3, 4, 5, 6. Okay, so 6 observations. Now if you take 6 by 2,
3.5.
which is 3, but if you say this is median, if you observe, to the right of 3 and the left of 3, it is not equally divided. right? So to the left of 3, there are only 2 observations, but to the right of 3, there are 3 observations. So it is not equally divided. So I'll have to choose somewhere in between these 3 and 4, right? So we'll just take mean of it, mean of 3 and 4, and that will give us the median.
Sir, can we choose any value between 3 and 4?
No, right? The standard is you have
Exact
to
mid
take the
value.
mean of it.
You should get exact mid value.
Yeah, you should take, it will not be exact middle, it will be the mean.
Okay, sir.
Okay. So the median will be 3 plus 4 by 2, which is 3.5. Okay. So now within the next 10 minutes, I will wrap all this mean, median, mode, everything with taking a nice data set. Let's take a data set with 10 observations. Okay. 3, 4, 4, 8, 5, 10, 4, 8, and 9, and 5. Okay. So if I have to compute the mean of this data set, as we discussed, the formula is simple. So it is
Sum of
simply,
all observations by total number of observations.
yeah, sum of all observations. You write everything and divide it by the total number of observations, which will be 10. If you compute, you can see that 3, 4, 7, 7, 4, 11, 11, 19, 5, 24, 34, 38, 46, 55, 60. Right? So 60 divided by 10 will be 6. So the mean of this particular data set is 6. If I have to compute the median of this data set, for median, I will order this data set, right? So I'll write it in ascending order, starting from 3, 4, 4, 4, 5, 5, 8, 9, and 10. Correct? And since there are even number of observations, I should take
There is one more 8.
2 times 8.
2 times 8. Sorry. Yeah, so there is 8, 9, and 10. Since there are 10 observations, I have to take the mean of the 5th observation and the 6th observation. So the median will lie between these two data
That
points.
is 5.
5 plus 5 by 2
Gives 5 only.
gives us 5. So the median is 5. What is the mode of this data set?
Most
Look at
recurring
whichever
observation, that
the
is 4.
value has repeated most number of times. So if you see, 4 is repeated most 3 times. So mode is most repeated value in the data set, and that is 4. Now what is range of this data set?
10
Range is
minus.
basically
Can we say 3 to 10?
So the range is basically maximum value in the data set, maximum value in data set minus minimum value in data set. So what is the maximum value that is there in the data set, which is 10?
10.
And the minimum value is 3. So the range will be
7.
10 minus 3, which is 7. Okay. Next comes variance. How do I compute the variance? Variance is basically the spread of the data set. So the variance, actually we'll consider population variance. Okay, so for population variance, we should subtract the mean from each data point. So firstly, we have to compute the mean. Let's say X bar is the mean, and we have to subtract mean from every data point and then square it and then sum it divided by the number of
Total number of
observations. So n is the number of observations, and x bar is the mean, and xi's are the data points. And you have to take this summation starting from I is equals to 1 to capital N. So in our case, capital N is 10, and we have all xi's. So x1 is 3, x2 is 4, x3 is 4, x4 is 8, and then x5 is 5, and so on, right? So x10 will be last data point, which is 5. Okay, so if you do this computation, so this will be, we have x bar also, this is x bar, right? 6. So 3 minus 6 whole square plus 4 minus 6 whole square plus, so it will be like that. So 3 minus 6 whole square plus 4 minus 6 whole square plus 4 minus 6 whole square plus, and so on till the last data point, which is 5 minus 6 whole square whole divided by 10 will be the variance. So I think it will come out to be, I have computed it, but you can also compute it. It will turn out to be 5.6. Correct me if this is wrong, okay? So this is the population variance. And there is a subtle difference between sample variance and population variance in order to make it unbiased estimator. So this comes in stats 2, okay? So don't worry why I have to divide it by n minus 1, why not n. We will debate this in stats 2 course. Okay, so there is a proper justification, mathematical proof why sample variance, when you compute sample variance,
n minus
you have
1.
to divide it by n minus 1, not n. Okay, so that's the only subtle difference. Okay, and for computing standard deviation, you have to take
Root of variance.
yes.
root
So
of
standard
variance.
deviation is just square root of
Variance.
variance, which is square root of 5.6.
Sir, I have a doubt here.
Yes.
Sir, what will be the symbol of population variance, like sigma or sigma square?
Population variance will be sigma square, right?
Standard deviation is sigma.
Standard deviation is sigma. Okay.
When we are asked to calculate population variance, we are calculating the square one. Like it is sigma square only.
Correct, correct. So it will just be this. You don't have, you should not take the square root.
Okay, sir.
Okay. Yeah. And next comes the quartiles, which are Q1, Q2, Q3. Right. So Q1, if you have to understand it in very simple layman terms, Q1 is basically the median of the lower half.
Oh.
Sorry. Can everybody please be on mute, please? Okay. And Q2 is exactly the median. And Q3 is the median of upper half. So it is 25 percentile. Q2 is 50 percentile. Q3 is 75 percentile. Okay. So, and how do we compute it? It's basically percentile is like P. You compute NP value, where N is again the number of observations into the percentile. If it is odd, if it is not integer, then you take the next observation. If it is integer, you take that integer and the next integer divided by 2. Right? So that is how quartiles are computed. We will compute Q1, Q2, Q3 for this particular data set. Okay. So again, for computing quartiles also, you have to write your data set in ascending order. Okay, so let's take this data set 3, 4, 4, 4, 5, 5, 8, 8, 9, 10. So 10 data points. So the lower half is this, and the upper half is this, right? So you can see from if the data points are only 10 or near to 15 or 20, you can separate them into lower half and upper half. And once you separate them, you can clearly see that the median of the lower half is 4 and the median of the upper half is 8. So this will be Q1, this will be Q3, and Q2 is exactly the median, right? Does it look like a shortcut? No. Formula, if you are comfortable with formula, you can go ahead with formula. But here, this also you can follow. So 4, 5 and 8 are Q1, Q2 and Q3. Any doubts here? Is this okay?
Yes, sir. Fine.
Q1 is
With 5,
basically,
sir.
sorry?
The Q2 is 5 or the average of those two?
That is average, and both are 5 and 5, right? 5 plus 5 by 2 gives us 5 only.
Okay. In general, as this case is 5 and 5, if it is some other number, then we have
Some other
to
number also, you take the average, mean of it.
Okay.
And sir, if we have odd number of objects, then how will we divide them in two halves?
We
So
can take
then,
direct number. Then.
so it will give you the direct number, right? So
But how
1,
will
2,
we compute Q1 and Q3?
Okay, okay. So then, like, if it is 1, 2, 3, 4, 5, then Q2 will be 3, and Q1 and Q2 will be Q1 will be the mean of 1 and 2, and Q3 will be mean of 4 and 5. Is that correct?
4 and 5. Yeah. It should be
Okay.
like that only, right? So 5 times.
Okay.
If I want 25 percentile, it is 1 by 4. Okay, it is 1.25. So you will take the next observation. Okay, so if it is odd number of observations, you take the middle number in both upper half and the lower half. Okay, so that's a good question. So what I mean is, so if you have odd number of observations, let's say 1, 2, 3, 4, 5, 6, 7. Okay. So here Q2 is very easy.
4.
Q2 is 4. So since you are able to get Q2 as 4, which is a data point, you take the lower half to be 1, 2, 3, 4. Should I take like this? What is this?
We can consider lower half as 1 to 3 alone. Can we? Then the median, like Q1 will be 2 and Q3 will be 6. If we consider 1, 2, 3 as lower half and 5, 6, 7 as upper half. I don't think it is correct or not. I don't know.
No, that is correct, right? So 7 by 4 is 1.75th observation is 25th percentile. And 7 into 3 by 4 is 21 by 4, which is almost 6 point.
But it is not equal to 2 and 6, right? It is like approximately almost near, not the exact one. So we should go with formula, I guess.
No. Yeah. Mostly for odd, it won't be. For odd cases, I think you just have to use formula. For even cases, it will work. For odd number of observations, maybe what we can do.
So can you provide the formula for that?
Yeah, formula is basically you should do n times p. Okay, where p is just the percentile. So if we ask you 25 percentile, P will be 25 by 100.
So if the observations, you are taking a continuous observation, right? If it is something other observations like not a continuous one or something, then
This is also not a continuous one, right? This also has. Okay, let me clarify this clearly. So
I'm
if
saying like in the example down in the next page in the example, if you take Q1, that means it should be 10 into 25. 25%. That means 1 by 4. 10 into 1 by 4, right?
10 into 1 by 4, correct. It
That
will
means
be
2.5.
2.5. So you have
It
to
is
take
not
the
4.
next integer.
Okay, 2.5.
See,
That means it will be
2.5 is
3.
the observation, right?
Okay, okay.
So you should take the third observation
Third
as the
observation.
25th percentile. Yeah.
So
So if
that
it
is
is
the 2.5th observation, right?
2.5th observation, but since it is 2.5, which is not an integer, you should take the next observation as the 25th percentile. So 25th percentile is basically 25% of the data is lesser than that.
Sir, like that, if we got 2.5, we have to round off to 3.
You should round off to 3, which is third observation. If you got an integer, okay, if it is not an integer, if this NP that you compute is not an integer, you take the next observation.
So if NP we get 3, then we can just take third observation, right?
No. So if NP is an integer, then you should take the mean of this integer and the next observation.
So now in the case of 1, 2, 3, 4, 5, Q1 should be actually n into P. That means 5 into 1 by 4. That will get us 1.25. That means you have to take us 2 or 1. First observation or second observation? That I'm asking.
We are getting how much?
1.25.
Anything above 1, you should take the next observation.
So in this case, Q1 will be 2, Q2 will be 3, and Q3 will be 4, right? For 1, 2, 3, 4, and 5.
1, 2, 3, 4, and 5, yes. Q1 will be 2, Q2 will be 3,
3, Q3 will be 4.
Q3 will be 4. Correct.
So when we get NP, we from NP, if for example in this example we get anything which is greater than 1 and less than equal to 2, we have to take second observation.
Second
right?
observation, correct.
And again, anything more than 2 and less than 3, third observation.
Third observation, correct.
So in case of odd or even, we can do in this method also, your shortcut method, which is it is fine, sir. Actually,
If it is even, then it's very easy. This is
even
this
odd
shortcut
also
will
we can do. The before example, your 7 observation are there now. Here we got to Q2 as 4. Then after that, out of these 3, the middle one is the Q1, and out of those 3, the middle one is Q3. That means 2 is Q1, 4 is Q2, and 6 is Q3. We'll get.
And so
Yeah,
in the
you
formula, n times P is percentile and n is the total number of observations, right?
Correct. So
And whenever we are
is
getting decimal, we should get the next next nearest integer.
yes.
And if we get integer, then we should take mean of that integer and the next observation.
The next integer, yes.
Oh,
The
okay.
position.
Position. It's mean of ith observation and I plus 1th observation.
So here when we get the decimal value, it's not like rounding off. We are just trying to get the next highest integer. It's not
Correct.
like rounding off, right?
If you know floor function, right? How many of you know floor?
Yeah, float, yes.
Floor. So it's like, it's not floor. It's like
floor.
You should take the next. Anything 1.01 also goes to 2.
They say ceiling value.
Sorry,
That's
ceiling value. Yeah. So you think of it like ceiling value. So you take the next observation, not the below one. You go to the next one.
Okay.
So here, it is not that median is always Q2. We need to see Median and percentile will not always be related.
So I kind of got wrong in my last session. Actually, Q2 is exactly the median. So I have gone back and saw that some of the textbooks also mentioned this. So where this Q2 is exactly the median. So here also, if you compute the 50th percentile, what is NP? We will compute Q2
10
here.
into 1 by 2, 5.
N into 1 by 2, which is 5, right?
And
So
fifth observation we have to
5
take.
is an integer. So you cannot take
Okay.
directly the fifth observation. Rather,
Okay.
you should take, since it is an integer, you should take the fifth observation and the sixth observation mean, which is
Fine.
nothing but the median here,
Okay.
right?
So Q2 can the value of Q2 we can get decimal also. Value. I'm not saying the observation.
Yeah.
Okay.
You can get
Okay.
the Q2 is
Decimal
exactly
value.
the median. Q2 you forget,
Fine.
you don't compute it with NP or something. Q2 you
Fine.
compute it as median itself. Okay, Q2 is nothing but median.
So take one more observation like 1, 2, 3, 4 alone. 1, 2,
Okay.
3, 4 alone.
Mm-hmm.
In that Q2 will be median of 2 and 3.
Yes, Q2 will be median of 2 and 3, right?
What is Q1 then? How to take Q1 and Q3? That alone can you say?
Just a second. What is happening?
Q1 will be mean of 1 and 2 and Q3 will be mean of 3 and 4.
Okay, so 1, 2, 3, 4, right?
Huh.
Now if I have to compute the median, since these are even number of observations, I can do it very easily. Okay, so what will I do is, I will separate the lower half and the upper half. Okay, so I will compute
Fine.
median of this, which is
1.5.
1 plus 2 by 2, which is 1.5. And the median of this,
3.5.
which is 3 plus 4 by 2, 3.5. And Q2, so this is Q1, this is Q2.
Q3.
And
Q3, sir.
Q3 will be exact, sorry, this is Q3. Q2 will be exactly the median. And the median is 2 plus 3 by 2.
By 2.
Which
Fine.
is 5 by 2, which is
2.5.
2.5. Even if you go by formula. Okay, so.
But we should not take the decimal, no, sir. Then we have to take the next value. Then
it
how
is
can
not
we
the
fix it?
observation.
No,
it
it
is a
is
value.
not the observation value. This is the value. Directly the value we computed.
Yeah, we have taken the value, but the Q3 is exactly you are saying the 2.5. Okay.
3.5. So we will do it by NP also. No, you will get much more clarity.
Okay.
So NP for 25th percentile, N is 4 and 25th percentile is 1 by 4, right? And I'm going to get 1, which is an integer. So 1 is an integer. So if you just scroll up, if your NP is an integer, then you should take the mean of that integer and the next to that integer observation. So this 1 is first observation. Okay. So this first observation, since it is an integer, NP giving me an integer, I should take the first observation and the second observation mean. So what is the first observation value, which is 1? Second observation value is 2. So 1 plus 2 by 2 gives me 1.5, which will be Q1. Even if I go by formula or with the shortcut that I just said, for both the cases, Q1 is 1.5.
Sir, compute Q3 using formula.
So if we compute Q3,
3.5.
3 into, sorry, N is
4.
4.
4.
P is 3 by 4, which gives us 3.
3.
Again,
So
3
as we get
is,
integer, so we should
as we are
okay.
getting an integer, third observation plus the next observation, fourth observation's mean.
By 2.
Which is third observation value is 3, fourth observation value is 4. 3 plus 4 by 2 gives me Q3.
Absolutely fine, sir.
Okay. Is this clear for all of you?
Yes, sir.
Sir, means that we are getting 1.5. So do we need to round it off to 2 or do we need to round it off to 1 for the Q1 value?
Okay, so there is no rounding off here. Okay.
Okay.
So there is computation of NP and computation of Q1 directly. So the shortcut that I gave was using the observations itself. Okay. And when you do NP using formula, the value that you are going to get is related to the observation, is associated with observation, not the dataset values. Okay. Okay. So by formula, if you go, the value that you are going to compute, which is NP, if it is integer, then that integer will be the observation, not the value. So it's like here we got 1. So it is first observation. So you go back to your data set and see what is the first observation. And since it is an integer, you take the first observation and the second observation's mean. That will give you Q1. Okay. If you use the formula. So here also it is 1.5. Here also it is 3.5. So here in this particular data set, there is no rounding off. Q1 is basically 1.5. Q3 is basically 3.5. And Q2 is 2.5. Okay, so these are values. These are exactly the Q1, Q2, Q3. Is this
Yes, sir.
okay?
Yes,
Huh.
sir.
If you are too confused, just follow only one method. Don't get confused with the two things.
Yes, sir.
Okay,
So
if
now
people who
this,
are confused with NP, I just gave a shortcut that you divide your data set into two halves. Call it one as lower half, one as upper half. Then computing median is easy for us, right? So then I said you compute the median of the lower half, which will give you Q1. Compute the median of upper half, which will give you Q3. And compute the median, which will give you Q2.
So above Q3, there is another 25% of the observations are there above Q3.
Correct.
So each comprises of 25%. So Q1 is 125% and Q2 is another 25 and Q3 is another 25. There is another 25 which we are not
to the
considering.
right of Q3.
Q3.
Correct. Correct.
So Q2 50%, what we are considering is Q1 plus Q2, no sir?
Q1 plus
Plus
Q2.
Q2. Then only it is 50%.
For Q2, yeah, is basically
Cumulative.
all the data points that are
From
lesser than
Q1.
Q1 and between Q1 and Q2 also. Okay.
Could you please emphasize on this point once again?
So
Points.
Q2 contains 50% of the data to the left of it and 50% of the data to the right of it.
Right, sir.
Okay. Q1 contains 25% of the data to the left of it and 75% of the data to the right of it. Q3 contains 25% of the data to the right of it and 75% of the data to the left of it.
Yes, sir.
Okay. So one small diagram will clear. So if you have the whole, you take a scale. Okay. So you divide this into 4 components. 4 equal components. Okay. So 25% is this. Another 25% is this. Another 25. 25. Okay, so this is 25% of the data. So this is Q1. And there is another 25% of the data followed by Q2. Now, if you see Q2 to the left, it has 50% of the data. And to the right also, it will have 50% of the data. And this will be Q3. Okay. Simple. Got it? So Q1, Q2, Q3 divides the data set into 4 equal components. All right, so we are almost very much delayed. Let's proceed. So if things are not happening fine, then we will do half of week 4 tomorrow. We'll have to do tomorrow. Okay. So now let's proceed quickly. Let's finish this off. Interquartile ranges, once you compute these quartiles, interquartile ranges Q3 minus Q1, right? Which is 8 minus 4, which is 4. Okay.
So can we get the sheet somewhere?
Which sheet?
And the whole you did summary.
These things we will upload after this session. Okay.
Where would you go?
It will be in the supplementary contents on. You can check. Okay. So let's proceed quickly. So what happens if I add some value to every data set? Right. So for each observation, if I add some scalar, what will happen to this mean, median, mode, everything? Okay. So this time we will do real quick.
Everything will be same, sir. If you add a
So
constant, it doesn't change.
yes, if you add a constant, mean will change. Right. So it will be 8, 9, 9, 13, 10, 15, 9, 13, 14 and
14, 10.
So if you compute the mean, you will see that mean will be shifted by 5 units. Right. So if you compute the mean of this 8 plus 9 plus 9 plus 13 and so on plus 10 by 10, you will see that the mean will be 11. Right. You compute and see. You can quickly compute and see. Mean will be 11. The observation is earlier mean is 6 and whatever the value that we added value. So that much amount the mean will shift and that will shift. So here we added it. So mean will increase by 5. Okay. So what will happen to the median? You order it and even the order after ordering also you can clearly see once you order we will see that 13 will be the median. Right. So you can order them and see. Since 5 is the median in the previous data set, in the new data set, 13 will be the median. And even here also, new value will be 13. Here also, earlier
The
it is
new
5.
value should be 10 of median.
Sorry, 10, right? Sorry. Why that? Previously, the median is 5, right? So, the new median will be 10. And again, you can clearly see that the old median is increased. The new median is increased by 5 from the old. So, this will be added. This is the added value and median also will shift by 5 units. What happens to mode? Mode will also, mode you can clearly see it is 9. Again, earlier mode is 4. Again, it is added by 5 units. And what will be the range?
7.
So the least value is 8 and the maximum value is 15. So 15 minus 8 will give us 7. So 7 and previous data set also the range is
7.
7. There will not be any change.
Any change.
So no change with respect to range. Even if you compute variance also, I'm pretty much sure
No
that it will
change.
say 5.6 and there will not be any change. Even if variance
Standard deviation
doesn't
also
change, standard deviation will also not change. Quartiles
increases.
Quartiles increases by
5
units. So Q1 will now become, so
Q1
earlier
plus 2.
values are 4, 5 and 8. So Q1 will be 4 plus 5. Q2 will be 5 plus 5. Q3 will be 8 plus 5, which is 9, 10 and 13. there is some change. Again, it's increased by every value is increased by 5. But when it comes to interquartile range, Q3 minus Q1 is 13 minus 9, which is 4.
No change.
Which is same as previous interquartile range. There is no change. If you see clearly, these first three measures are measure of central tendency. Right? So the center or middle value, centered value has been changed. Whereas the dispersion measures, so all these are dispersion measures, right? Or the spread. So when it comes to the spread, by adding a value, there will not be any change. So that is the observation you should make. Even the interquartile range also is not changing. So if you just add a value, adding a value just shifts all the values equally. So only the location, measure of location will change. So from this place, it will just shift the place, but not the spread. Okay. So that you have to observe. By multiplying some constant, so if you multiply a constant, then we'll see what happens to the mean, variance and everything. So the new data set will now become 9, 12, 12, 24, 15, 30, 12, 24, 27, 15. Right, so now if I compute the mean, what will happen to the mean? So even if you compute, sit and compute 15 by 10, if you compute, you will get the mean to be 18, which is 6 times 3. So this is the old value and this is the value that is multiplied. Value that is multiplied. So the new mean will get multiplied by 3. Okay. If I see the median, again, median will be 15.
That also will multiply by 3.
Yeah, so 15. This will also gets multiplied by 3. What will happen to the mode? Mode will be 12. This is also multiplied by 3. Now let's come to the range. So what is the range of this data set? New data set. So the minimum value is 9 and the maximum value is 30. So 30 minus 9 is the range, which is 21. So earlier range was 7. Now the new range was 21. Again, this also gets multiplied by 3. What will happen to the variance?
No change.
A squared unit will be multiplied.
Yeah. So variance will also change. When you compute this variance, no, you will see that variance will be 5.6 times 9, which is 3 square. So variance will be multiplied by
square of that number.
Square of the number that we multiplied, which is 9 in this case. Whereas standard deviation
multiplied by 3.
Yes, it will just be square root 5.6 into 3. This is again multiplied by 3. And when it comes to quartiles, Q1, Q2, Q3.
It will also get multiplied by 3.
Correct. So you can, so the first quartile will be 4, which is 12 here. 12. Q2 will be 15. And Q3 will be 24. 24. And everything will be multiplied by 3. When we compute interquartile range, Q3 minus Q1, which is 24 minus 12, which is 12. And this value is also multiplied by 3.
3.
So when you scale or multiply each and every data value, then both the center and the spread will change. Okay. So when you just simply add, only the location or the center will change. So addition will only change the location, not the spread. Whereas multiplication, it changes the location as well as it will stretch the data points or compress the data points. So like spread will be changing. Okay. So that's
Yes, sir.
about this mean, median, variance, standard deviation, interquartile ranges. So these are very important. Practice with different data sets. Compute all the measures with hand, and you can use calculator also. Calculator will also be available, but make sure you enter the values correctly. Okay. So yeah. So
So
that
could you please
summarize.
share this document?
Yeah, we will share. We'll share. Don't worry. That actually summarizes week 3. Okay. And next we'll move to week 4, and we'll try to cover most of the things. I'll try to cover this covariance first. Okay. And then
Sir, sorry to disrupt.
yes.
Sir, can we discuss correlation coefficient BICV?
Okay. So we'll start with association between two numerical variables, and then we'll
Yes.
see whether if there is time, I will come to association between two categorical variables. Okay.
Yes, sir, please.
Okay. So let's begin with association with two numerical variables. Okay.
Sir, if any topics are remaining, then will you discuss it tomorrow or what? What's the plan?
We'll see. See, what I believe is concentrating. See, human brain should also work continuously, right? And I believe our brains will not focus on one thing for more than 50 minutes. At least my brain will turn it off by 30 minutes. So I usually take breaks in between, but since there is no time, I would like to continue. But I would like to do a hard stop at 8 p.m. because 2 hours is quite lengthy. So if any topic is missed, tomorrow there is a mock session, right? So I will join that session and I will try to finish the remaining topics and then we'll discuss mock. Okay. So I hope that is better than I stretch this session by 1 more hour. Is that okay?
Yes, sir.
Okay.
Sir, I had
Okay,
a
sir.
doubt from the one of the PYQs. So, would I be able to ask that today or tomorrow in the mock session?
Most probably tomorrow only because if I start discussing this covariance and correlation, I think I'll take at least half an hour for it.
Okay, sir. So that is there in the calendar, right? The link.
Yeah, tomorrow mock has been we put it in the calendar, right? Tomorrow or day after tomorrow, I'm not really sure. If at all there is no session, also I will try to arrange one session. So if I miss something, okay.
Oh, so sir, are you gonna solve the mock for qualifier?
I think yes. Let me cross check and get back to you guys. Okay.
Okay, okay.
If there is such session, I will come in that session and finish the other topics. If there is
Yes,
Yes,
no
sir.
sir.
We
such
It is
have
there
a
session,
tomorrow,
session tomorrow.
8 to 10. There is mock session.
8 to 10 in the night, right?
Yes.
Yeah. Okay. So then maybe in the first 30 minutes or 40 minutes, I will come and finish the other topics that are left. And then we will do the mock. We'll continue with the mock.
The questions, right? Okay, sir.
Yes. Okay.
Okay. Thank you.
But today I would like to start with the association between two numerical variables because most of you guys have asked me for computing covariance and correlation coefficient, right? So let's do that and let's try to end this session here.
Sir,
And then we will.
could you also discuss the point by correlation that one today?
That is not needed. That is what I said, right? So you don't worry about association between a categorical variable and a numerical variable.
No, sir,
Okay.
but that is there in week 4, right?
That
That
is
is
there
part
in
of
the week
syllabus.
4, but see, we are the one who created the question papers, right? Since there are many topics to be covered, and we know that it's very difficult to cover all the topics, that is why I have given you important concepts. In that, I didn't mention saying that. So, but anyway, that is just a formula based, right? Formula driven concept. And if you know the formula, you can do it. If you don't know the formula, then you can't.
Yeah, so I know the formula, but there was a question from the PYQ where the formula which man gave it did not work. Like the answer was coming in negative, but
Okay.
the correct answer was positive.
Okay, we'll see. We'll see. Mostly we'll see that tomorrow. Okay.
Okay, sir. In the mock session, right?
Yeah, in the mock session we'll.
Sure, sir. Please
At least
continue.
kindly cover the important formulas so that we can prepare those at least.
I have given that, right? In the start of the session, I gave you what concepts you should
Uh,
focus on.
yes, no, for week 4, the what is it? Formula, how to use those things, can you cover?
Yeah, yeah. So that is what I'm going to do now. Whatever
Uh-huh.
the time that is left, if you could let me do it,
Yeah,
I'll just
that's
yeah. All right. So let's start with association between two numerical variables.
Interquartile range and the median are same.
Sorry.
Its interquartile range and the median are same or not?
Can you repeat?
Is the interquartile range and the median are same?
No, it's not same, right?
no.
Okay, sir.
Okay. So let me take an example directly. Okay. So let's not sit and discuss the theory part. So let's straight away take an example. Let's say there is two variables. One is age of car. How old is the car? Okay. Another one is price. So if I want to sell that, what is the price? So age of car in years and price in lakhs. Okay. So I wanted to see whether there is an association between these two. Association is like, is there any relation or is there any positive relation or negative relation with respect to this age and price? So as age increases, will the price increase? Or as age increases, will the price decrease? Can I say something about, given the age, can I say something about price or not? So that is what association is basically, right? How correlated these two features are. Okay, so given from the data, we can say whether they are associated or not. Associated is like whether they are correlated or not. Okay, so let me take simple 5 observations. Okay, so if the age of the car is 3 and the price is 5 lakhs. Okay, and age of the car is 4, the price is 4.5. Age of the car is 8, age of the car is 8, the price is 4. Age of the car is 4. Okay, so let's do this. Let's say 5 and 8 and 10. Okay, so 8 years old is 3, 10 years old, let's say it is 1. Okay, so this is rough example, and we have collected the data of 5 cars and their ages and their selling prices. Okay, so if I plot, the first thing is how do I represent this? And the representation is we can use the scatter plot. So scatter plots have x and y axis, and x axis contains one feature, which is age or car, age of car or price. You can put anything you want. And y axis contains the other feature. And each data is represented as a point, okay, on this xy plane. So it is 3 and 5. Age of the car is 3 and price is 5 lakhs. So 3 comma 5. You just have to plot 3 comma 5. Okay. This is 3 and this is 5. Similarly, the next data point will be 4 comma 4.5, which is this. Similarly, 5 comma 4 is this. And then 8 comma 3 will be this. And 10 comma 1 will be this. So since there are 5 data points, the scatter plot will look like this. Okay. So now looking at the graph itself, we can clearly see that as the age increases, the price is dropping. So that means there is some relation between these two. But we can't orally say there is some relation or how much the relation is. How do you measure this relation? Is basically computing this covariance and correlation. How do I compute the covariance? Right. So again, for variance, we had population variance and sample variance, right? Similarly, covariance also we have population covariance and sample covariance. And one of the easiest way to remember covariance formula is if I have two variables, let's say x and y. So the covariance x comma y is basically, if you want to connect it with variance, if these two features are the same, okay, x and x, it will simply be variance of that x. Okay, so what is variance of x? It is summation xi minus x bar whole square by n. So I'm
By
talking
n.
about population variance only. Okay, so if it is sample, only difference will be denominator will change. So this is variance. So what I will do, I will write this as xi minus x bar whole square as xi minus x bar into xi minus x bar divided by n. Since I have both features as x and x, it is xi minus x bar into xi minus x bar. If I have x and y, two different features, then the covariance of x comma y will be summation xi minus x bar into, instead of instead of other xi minus x bar, we will have yi minus y bar divided by n. That's it. So if I just simply replace y by x, then I'll just simply get covariance of, variance of x. So what I said is, remember this, covariance of x comma x, covariance of x comma x is nothing but variance of x. Okay. So let's compute covariance for this data. Okay. So for that, we will have to draw a bigger table. So is this okay, this formula? So this is how easy to remember covariance formula. Okay, you compare it with variance. So variance, if you remember, you associate it with covariance. Okay.
Sir,
Yeah.
sir, I have a doubt. I have like covariance of x comma y can be written as covariance of x plus covariance of y or
So
multiply.
no, right? So covariance co is like, what do you mean by co? It is like combined variance. Covariance is like you
Combined variance.
combine both the features and see the spread.
Yes.
Okay. So there is no
Yes.
covariance of x. Okay, because there is only one feature. You are taking only one variable. So one variable will not have combined variance. It will just have variance. Okay, for covariance, you need two variables. Okay, so that is why I wrote covariance of x comma x. So I have taken the same variable twice.
Okay.
Okay, so covariance is only between two variables, whereas variance is for single variable. So covariance of x comma y is not covariance of x into covariance of y or covariance of x plus covariance of y. So there is no covariance of x first of all. Okay. Is this clear for everyone? I know this is a common misconception all of us will have. Covariance of x comma y can be covariance of x plus covariance of y or covariance of x into covariance of y. Okay.
Okay.
So,
Now take
so that is now how covariance is defined. Covariance is basically the variance of the combined data set. Okay.
Mm.
So let's compute that covariance. For that covariance, as we can see, in order to compute that, we need mean of the first variable, mean of the second variable. We will compute them. So we'll compute the mean here.
So first variable we are taking as age of the car and second is price, right?
Even if you interchange, it doesn't matter, right? So the formula is symmetric.
Yeah, I get it.
So covariance, so that is also one property of covariance. So covariance of x comma y is same as covariance of y comma x. Okay, it doesn't matter which feature you take first. Okay,
Okay.
so this is also. So age of the car, if you take the mean, it is 3 plus 4 is 7, 7 plus 5 is 12, 12 plus 8 is 20, 20 plus 10 is 30. 30 divided by
Sir,
5 is?
I got a doubt. If this table is a continuous, then how we will be doing?
Continuous, you mean?
Like 3 to 4 years as one, they give prices 5. 4 to 5 years, if it is between 4 to 5 years, then 4.5
Okay,
like that.
so then that comes in a different way, right? So that becomes categorical again. So it's like class
Okay.
intervals and it
Then
will go
how to
into
find
discrete
the
case.
covariables?
So then it will go into that bilateral we have, right? Point by series serial correlation coefficient. It will go into that case.
Fine.
So this covariance is between two numerical variables, where this numerical variables are like this. It's
So
not
can,
class. It is
so can we also do that? We take a midpoint, how we calculate in the mean, and then we calculate in the same way for two numerical.
no, not exactly like that. So it will see once you group it into classes. Now classes will become a group, right? Each class is a group. So it's like uh, one categorical value. So it will go into that. So it should not be like that. Okay, so this covariance and this correlation coefficient is
Will they
computed
ask like
only.
that, sir?
Uh, will they ask like that? Is like you're asking me, will you ask that question or not? as I said, so this point bilateral thing, we sort of skipping it because it is just the formula and it requires lot of computation and
Yes.
it will kill lot of time in one question itself, right? So
Yes, sir.
that is why we are skipping that. If you ask me the concept is important or not, yes, it is important for your future courses. But if you ask me, is it important for quiz 1 or not, then I would say prepare it at the end. So if you have time, you just look at the formula. That's it.
Okay. Okay.
Okay. So let's compute this. So for that, we need mean, which is x bar. And we'll also compute y bar. Right. Y bar is like 5 plus 4 is 9. 9 plus 3 is 10. 9 plus 3 is 12. 12 plus 1 is 13. 13 plus 4.5 is 17.5. 17.5 divided by 5 is 3 point. 3.5 3.5 or 3.75? No, 3 point. Oh my God. So this is what I said.
5.
So after 2 hours
Yeah,
of
3.5.
session,
3.5.
3.5 is it? Okay. So it will be 3.5. Okay, so once we have this means and all the data points, so this is like x1, x2, x3, x4, x5. Right, so y1, y2, y3, y4, and y5. Right, so for covariance of this two variables is summation xi minus x bar is 6 into yi minus 3.5 whole divided by n is 5 here. Okay, again I goes from 1 to 5 and you can compute this. So you take the first observation, which is x1, which is 3 minus 6 into, and yi is, y1 is 5, 5 minus 3.5. This will be the value for with respect to the first observation.
Yes.
And plus,
4
if
minus
I
6.
is 2, then it will be 4 minus 6
4 minus 6
into 4.5 minus
4.5 minus
3.5.
3.5.
So likewise, you write the third, 4, and the final one will be 10 minus 6 into 1 minus 3.5 whole divided by 5. And you compute the value. That will be the covariance. Okay. Now, we have covariance. What is the use of correlation? Coefficient, right? So covariance actually gives us the spread. How much is the spread? How is the spread combinedly, right? So it will only give a positive value to us, right? It will not tell whether two variables are correlated but in the opposite direction, or is it correlated in the same direction, and how much exactly is the correlation, right? So for that we need correlation coefficient. It is basically a measure of linear association between these two numerical variables, and that is derived from covariance only. So for computing this Pearson's correlation coefficient, okay, so for computing this Pearson's correlation coefficient, which is in general denoted as R, it is basically covariance of this x comma y divided by standard deviation of x, or we will represent it as SD of x. So it's not variance of it, it is standard deviation of x into standard deviation of y.
The standard deviation is population or sample?
Sorry? Standard deviation of
Oh,
population only. So we are just discussing with populations only, everything. If it is sample, then here correlation for sample and population, it doesn't matter, right? Because even for covariance, it will be for sample, it will be divided by n minus 1, and denominator also will have n minus 1, which will get cancelled out. If it is divided by n and divided by n, and then will get cancelled out. So if you write it this explicitly, covariance of xy will be summation xi minus x bar into yi minus y bar whole divided by n, and divided by standard deviation is square root of summation xi minus x bar whole square whole divided by n into square root of summation yi minus y bar whole square divided by n. So you can see that this n and the square root and the square root n will get cancelled out. If it is sample, it will be n minus 1, n minus 1, n minus 1. Even then also it will get cancelled out.
okay.
So this will be summation xi minus x bar into yi minus y bar whole divided by square root summation xi minus x bar whole square into square root summation yi minus y bar whole square. Okay. So for computing this correlation coefficient, we need many things. Not only xi, y. So we need xi,
Deviation.
yi, and this xi minus x bar whole square, which comes from computing the variance of the first variable. And also we need yi minus y bar whole square. And also we need this xi minus x bar into yi minus y bar. Okay, so we need all these things. We compute for every data point. All these things for every data point. So you have to compute for every data point all these 5 things. And then you add this, you add this, you add this, and you take this value divided by product of square roots of these two values.
So this covariance can be negative as well, right?
Yeah. See, this covariance also can be negative. But the point is, the value that you are going to get will be from minus infinite to plus infinite. And we will see the value 10 for a covariance and 25 for a covariance. You cannot say whether 10 and 25 are is 10 better than 25 or 25 better than 10. Okay. So covariance basically depends on these values. Location basically. Location of x and y.
Sir, we have one question, means graded assignment. It was week 4 graded assignment. There was one question related with sequence wise, means correlation coefficient and then biserial correlation coefficient. So, can we solve that question?
Question number, please.
Question number 1 or
question number?
Question number 3 or 4. Let me check the assignment, please.
Okay.
But I'm sure it is graded assignment. Week 4.
Okay, is it like 1 plus BBK electronics or?
Yeah, that question. Yes.
Okay, what is the correlation coefficient between the sales of 1 plus and BBK? Is that the question?
4.
Yes, sir. Same question.
Okay.
Yeah, the 1 plus phones and that
BBK ones. Okay, so there is no much difference, right? So whatever the values that we took here, are slightly different. That's it, right? So is the answer that you are getting is wrong?
Hello,
or
sir.
So if we go with that
Sir,
example, it
sir,
will
it
be
is
much
too
clarified, sir.
lengthy, and we are not means it is too lengthy, and when we go to conclusion, it is answer is not coming correct.
Okay.
Sir, could
So
you please have a look
how
of
to
that
make sure
question,
that
sir?
answer is correct means step by step. We just wanted to solve this,
Okay.
if
Sir,
possible.
one doubt. Sir, in the formula of correlation coefficient, you cancelled the n from denominator and numerator. How did you do that?
How did I do that?
Like it is multiplied, no, in the bottom it is n square and in the top it is
It's
n.
not n square. There is square root, right?
Oh, acha,
It is
okay,
standard deviation, not
okay,
the
sir.
variance. So square root n into square root n is n, and that n will get cancelled out with the top n.
Okay, sir.
Okay. Okay. So then I will take that example itself.
Excuse me, sir.
Hmm.
So, one question I have is that if we are asked to calculate standard deviation, we'll calculate the sample one. But here it doesn't matter. Like correlation, it doesn't matter. We take
Yeah, correlation, it doesn't matter whether it is population or sample.
But if we are asked to find sample deviation, we'll find the sample one only.
Yeah,
Standard deviation.
covariance, if you ask you covariance, then it depends on what covariance they're asking. Is it sample covariance or population covariance?
And if they're asking to find just the standard deviation,
Standard deviation also the same thing, right? So if it depends on population variance or sample variance. So if they ask you to compute population standard deviation, then you have to compute population variance and take the square root of it.
okay, sir.
If they ask you to compute sample standard deviation, then compute sample variance and then divide it a square root.
Okay, sir.
Sir, in point serial, biserial, we have to use population standard deviation or sample standard deviation? Which is the in point biserial?
So there also, I think it depends
Sir,
on.
Sir, for this question, second number question, my answer came 1.48 and the accepted answer is 1.49. For the single decimal means a single point decimal difference, I got incorrect answer. So
Which
this
question?
is
Second
just
question.
yeah. Asking what is the population standard deviation of cells 1 plus. I entered the answer 1.48 and
Okay.
and they are saying 1.49 and 1.69. So how we will be sure in exam that it will be correct?
Okay, so I think you have computed it little incorrect. For population standard deviation, you have to do divided by n, right? If you had done with n minus 1, then
Yes, sir, I did it.
you did
Sir,
with
the
n.
range what they have given in my answer sheet is the type range is 1.31 to 1.51.
That is different.
What I
Yeah.
gave is 1.414. I got score 1.
Correct only. So for you.
But for her case, how it will differ, sir? For all the people, the answer should be the range should be one and the same, no?
No, right? So the values that given to you are different to Sweta. So in the question, there are some values, right? That 1 plus and BBK electronics.
Is this grade 4 assignment is the questions are not one and the same for all the students, sir?
No. So the values will change. Questions are the same, concepts are the same, but the values inside the question will change.
Okay.
For everyone. So depending upon that value, your answer will change.
Okay, sir. Got it.
Okay, so the values that I have is in my portal is so 1 plus and BBK. So 1 plus and BBK, my values are Chennai division, it is 5, 1, 3, 6, 2, 6, 5.
For Chennai division, for my one is dealer's location. Chennai division 1 plus is 6, 4, 3, and 4.
Okay, you have only 4 values.
Yeah, for Chennai, I have 4 values. And for Punjab, I have 3 values.
Yeah, that's it. But this is the order that I have. And BBK, I have 19, 19, 12, 13, 15, 17,
No,
19.
sir, I have the different. I
Yeah, you
have
will have the different, but it will not change, right? So the values are different. That's it. The process or the steps that you have to follow will be the same.
Yeah, the problem is one and the same. Okay.
Yeah, and so the method that you have to follow, the steps, series of steps that you have to follow will be the same. Final answer will change because the values are different. Okay. Firstly, for computing correlation, you follow these steps. First of all, compute the mean of each variable. Okay, so this will be your first step. Compute the means. So compute this x bar and this y bar. Okay, so this will be step 1. I will write step 1. Compute the means of 2 variables. Okay, this should be your step 1. Then step 2 is basically compute these values. Or compute xi minus x bar and yi minus y bar whole square. And xi minus x bar into yi minus y bar. Okay. So compute these values for all observations. Okay, so that means you write the table like this: xi minus x bar whole square, yi minus y bar whole square, and xi minus x bar into yi minus y bar. So you should be really careful when you deal with numbers. Okay.
So sorry to interrupt. Here is the difference, right? Means xi x square xi x square whole square, and here it is you are writing xi x bar into yi y bar. So which means here is the difference, right?
Okay, so because the correlation
we have to take one more column then.
What is that column?
Means xi x bar should be there, na? Here it is whole square.
So the formula we need xi x bar whole square only, right?
No, sir. What I'm saying that here we are writing xi x bar into yi y bar, but we have xi x bar whole square and yi y bar whole square. So what here is the confusion.
There is no hard and fast rule, right? That you have to construct this way only. You can add that column, right?
You can add that column also, right? If you want, you can add one more column which computes xi minus x bar, and you can add one more column which computes yi minus y bar, and then take the product of those two.
Yeah. Okay, sir.
Okay. Okay, so there is no harm of adding those columns. But xi minus x, see, for computing xi minus x bar whole square, you have to compute xi minus x bar, right? No?
Yes,
Yes,
but we write the answer means we don't
It
mention
will,
the two
okay,
numbers.
you can write it. And
Yeah.
okay, so this is the x bar and this is y bar. You can compute the values. Then this is like 5 minus x bar whole square value, you write it here. Then this will be 19 minus y bar whole square value, you write it here. And then 5 minus x bar into 19 minus y bar, you write it here. Similarly, you fill all these values. Okay, so second one, it will be 1 minus x bar whole square. This is 19 minus y bar whole square. And this will be 1 minus x bar into 19 minus y bar. So like this you fill, and finally you will have 5 minus x bar whole square here, 19 minus y bar whole square here, and this will be 5 minus x bar into 19 minus y bar. So once you have this, then take the sum. Then compute the sum of this column. Similarly, sum of this column, sum of this column. Okay. So that sum will be summation xi minus x bar whole square. This sum will be summation yi minus y bar whole square. And this will be summation xi minus x bar into yi minus y bar. Okay. So this will be the numerator. Now once you have this table, now comes step 3. Step 3 is add all the values in each of the third, fourth, and fifth columns. Okay, so this is third, fourth, and fifth columns. Add all the values separately, which will give us this. Okay, then step 4 is compute correlation coefficient. How do I compute? R is equals to, once we have these values, these 3 values, you take the square root of the first 2 values, right? It is simply just take this value in the third value in the numerator, divided by, take the square root of this multiplied by square root of this. So this 4 steps will be common for any data point, any data values that are given here. So for me, these are the values. So my answer will change compared to your answers. But the series or the steps that I have to follow are should start from computing the mean. Then compute these 3 things for every observation. Then add the individual columns to get these. And then take and then compute this. Okay. Is this okay?
Sir, I
Hmm.
have one number. Can I share that and please solve that? Means it is in the test book, but I don't know how it came the answer.
Which one is that?
Xi x bar and y bar equals to minus 71.8935 by root 179.7335 and root 2 at 0.7575 equals to minus 1. How it comes? So I just wanted to know.
Or can you repeat? 7?
Yes, xi x bar and yi y bar equals to minus 71 point
X bar or summation? Summation. The
summation
numeric.
and I equals to 1 means I am just going with the number.
Okay.
Okay. Point 8935 as well. 8935.
8935. Okay.
8935. Yes. Root under root 179.7335.
Hmm.
Another root
Hmm.
28.7575.
Okay. You
And
just have to
answer,
compute this, is it?
yes, I want to compute this.
This you can use calculators, right? What are you getting?
In the book, it is minus 1. I just wanted to know how to calculate this and get the answer minus 1.
Okay, forget about the textbook. Did you compute by yourself?
I tried, but I'm not getting the answer.
Leave the answer. What value did you get? So this is minus 71.8935. You can compute square root of 179, whatever odd 7335. You can compute this square root. Yes, right? Use calculator. If it's very hard to compute calculate square root 179 exactly. But you can use calculator, right? Use the calculator and compute this value and see, no?
Yes, sir, we are getting approximately minus 1 to this.
Then that is how they have given, right? See, calculating this value is not that difficult.
Do you have this calculator?
Sorry?
Do you have this calculator on your system?
Okay. Should I
Sir,
do it?
please. Yes, please.
Okay. Okay, so let me do this. Minus 7.8935, right? So if I take the square root of 179 179.7335, right? Just a sec. So square root of 7335. It is coming out to be 13.406. Right? So this is
For me, it
13.4.
is coming 13.3922.
Okay, that.
Oh, sorry. Let me. I think there is.
Okay, even if it is 13.39, it is very close to 13.40. Then you can compute square root of 28.7575. Which is coming out to be 5.36. Right? So 13.406 into 5.36, which is coming out to be 71.85. So 70 minus 71.8935 divided by 71.85. It is approximately minus 1, right?
Oh, okay, sir. Thank you.
Yeah. All right. So this is how we should compute the correlation coefficient. Okay. And covariance is also really okay to compute now, right?
How to
Then
understand the relation between means it is strong, weak, or
so if the correlation coefficient is 1 or -1 or very near to 1 or -1, then they are correlated to each other. Anything around 0 is not correlated at all. Okay.
so -1 is strong positive relation?
Yeah, strong negative correlation.
Okay.
They are strongly correlated, but in the negative sense. Negative sense, I mean, if one variable value is increasing, the other variable value decreases.
Sir, if we have a R value of 0.3, let's say, which is near to 0.5, will that be like counted as a moderate one, or is it a weak?
Actually, it will not be counted as moderate one. So anything above 0.7 is considered to be strongly correlated.
So what's the range of a moderate one?
Moderate, you can think of it like this is not standard. There is no standard thing for this, but usually we take somewhere around 0.5 to 0.7 or 0.4 to 0.7 is moderate.
Okay.
Okay, so there is no moderately correlated. It is just the sense that we use. That's it.
We have some
So
questions around it in the graded assignment. So I've seen that kind of.
so that is what I said. So anything lesser than 0.7 and slightly above 0.3 or 0.4 is moderate. Anything close to 0 is not correlated.
Okay. Okay. Thank you.
Yeah. Okay. All right. So we have extended more than 20 minutes. I think I am still left with this association between two categorical variables, but that is relatively easier compared to association between two numerical variables. So that we will do tomorrow. Okay. So apart from that, I think I have covered most of the things. So these are the important concepts that I have said. So I have covered most of the things except this association between two categorical variables and how do we compute. In that also, how do we compute this row relative frequencies and column relative frequencies. So that is the only thing that is left, which we'll do tomorrow. Okay.
Okay, sir.
And
Thank you.
yeah. Thanks all for joining and have a great day.